Well, howdy there, Brad fans. Thanks for tuning in, and we got a classic two Brad for you. Both Brads are here, and we're doing what we usually do when both Brads get together, and that is talk about diseases. It's a heavy, heavy disease episode, this episode, and we start off with a short Ebola update with the Ebola situation in the Democratic Republic of Congo. We talked about malaria, some not so good signs of resistance in the malaria parasite, and a little more about coronavirus and where it came from, how it came from bats to humans. Spoiler, via the lab. Just kidding. Doesn't look that way. No evidence for that yet. And then we also threw in some space stuff, a little chat about SpaceX and one of the lesser known projects that they were up to. The big launch of Dragon, whatever it's called, got a lot of press, but we touched on one of the other projects they're working on. So thank you for tuning in. I hope you enjoy it. It was great to be back in the saddle with my good friend Brad. If you like what we're doing and want to get in the saddle, follow us on Twitter or Instagram at 2BradForYou. Rate, subscribe, wherever you're getting your podcasts. Throw us some stars. Throw us a couple sentences. Let us know how we're doing. Throw a question in there if you have something that you want to talk about, or you want us to talk about, or if you want me to address it directly. Happy to do that. Our website, 2bradforyou.wordpress.com, as always, has all the links to the stuff, the studies and the stories we talk about. And there's a contact form there, so you can get in touch with us there as well if you don't do the social media, which is probably good for your mental health. Anywho, thank you so much. Like I said, please do get in touch with us, rate, subscribe, wherever you're getting your podcasts, and enjoy the episode.
Whoa. Well, I'm going to say we're back, but I'm back because, Flash, you've been riding this wagon solo for a little while now.
Man, I am glad to have you back. You don't know what it's like to have to do this by yourself. You don't know what it's like to listen to your own voice, back in perpetuity. Have no one to interrupt you. Have no one to correct
So
you.
saying it's quite nice.
In fact, now that I'm thinking about it, it's actually pretty good. I don't know if the listeners would agree, but hey, there you go.
The listeners have been moaning at me saying, is it really two Brad for you, or is it just one Brad for you from here on in? So it's nice to be back in the saddle, foot in the stirrups, and ready to ride both shotgun and whatever the non-shotgun lead role is, driver, I guess.
Let's just call it Maverick.
Yeah, well, as long as we're both Mavericks and none of us are Goose, because we know how that ends. Spoiler alert.
We know what happened to Goose. I mean, really, let's think about it. You could be Maverick or Iceman. Both are alphas. Both are top pilots.
That's true. Well, then, in that case,
you could be my wingman any day. Bullshit.
You
could be mine.
Well, in that case, then I'm being Maverick because he's obviously the cooler, despite the other one being called Iceman. So
Iceman's definitely way cooler.
Well,
he didn't have to go through all the emotional turmoil. He was already at peak performance.
But
remember that
Maverick went through all that emotional turmoil and still saved the day. So ultimately, the film is called Top Gun and it's about Maverick. It's not about Iceman, is it? He is literally just a patsy in the seat just to fill spaces and keep you happy. But not that I'm saying that's what you are, Flash. I'm just saying that's how the film works, and that's kind of what you've been badged as. But anyway, enough of that. Welcome. It's good to be back.
Yeah. You can be my wingman.
Bullshit. You can be mine. So that said, I am going to be your wingman because you've got the first story of the day. So load a missile in, set to lock, and fire away.
Here we go. Missile lock. To the age-old two Brad for you topic. That's right. It is the Ebola update.
I knew it was coming, and I'm still excited.
The Ebola update, folks. Thankfully, not a lot to update. Although just the other day there was 5 new cases, I believe. So in total, we're up to 79 cases and 33 deaths in this, the latest outbreak of Ebola in the Democratic Republic of Congo. If you remember from the last Ebola update, um, I think it was the last one that we did where it was like we had declared one outbreak finished,
And then bang.
and
Yeah.
but simultaneously there was another outbreak in the same country that started. And so the discussion last time was confirmation, more or less, that these two were distinct
Yeah.
outbreaks, or at least at the time they believed they were distinct outbreaks because there was no epidemiological link. So if you've been listening to any of the other podcasts, the solo podcasts that I just did, I talked a lot about the contact tracing and stuff like this in terms of outbreaks and whatnot, and how you would determine what an index case was. So, like, what would be the first case? Um, and that's what they did to determine that these were two separate outbreaks. They couldn't find any connection, personal or travel or otherwise, between these two spots. But they have since confirmed with genetic sequence analysis that the new virus circulating in the Equateur province in Western Democratic Republic of Congo is different from the one that infected more than 3,400 people in the eastern part of the country. So
Okay.
that was the last outbreak. And it also found that this virus is different or distinct from the previous one that was in the same region in 2018. And the investigation is still ongoing to determine the source of this latest outbreak, although it's likely that it originated from animals. Of Not surprising, that's where these
Yeah.
things come from. And my God, is it not hard to start keeping track of all these different Ebola outbreaks?
Well, and the fact that, yeah, different ones are breaking out with no link between them, I think that just shows that there's a reservoir in the animal population or
Somewhere.
somewhere, and that's got to be concerning, especially, okay, we have the vaccine now, and I know that's still being rolled out and it's not, being used widespread still, but I guess the good news is, as you said, we've not had that many cases, and I know when we talked about this last time, there was speculation that, because they didn't know where it had come from, they didn't know where patient zero was, whatever, it could be huge. So it's good news that it hasn't exploded.
Yeah, I mean the idea that it came from an animal source means that if that is true, that yeah, you found the first patient,
Right.
and so that you don't have unaccounted spreaders out there spreading it around, so you can kind of contain it, hopefully. And I mean, it feels like, I mean, when was the last time we did that podcast? It's got to be a couple months ago. So the fact that the cases haven't gone up that much is a good
Yeah.
sign. Um, Now, yeah, the fact that you're getting multiple, sort of outbreaks that aren't linked to each other, as you just said, is concerning, because it means that this thing is jumping from animals to humans more frequently.
Right. Yeah.
There's a number of there's been a number of papers released recently, obviously, as you know, pandemics, outbreaks, emerging zoonotic diseases is such a hot
I thought you were
topic
doing a
now.
Trump
I
impression
mean,
there for
let's
a minute, both with the voice and with the hands. That listeners can see the hands, but
folks can't see the hands, but I got the hands going. No, I was kind of just saying how it's in vogue, even
yeah.
though, we've been covering that here for years. Don't forget, we're the first, maybe not the first. You know what I
Well, we're
mean.
the savers of modern media,
Um,
Flash, so we can say whatever we like. We know this.
yeah, that's
Yeah.
true. That's correct. Yeah, fuck it. We have an explicit tag too, so I can say that as well.
PG
Um,
13 plus.
But you know what I mean? It's like there's been a number of papers that have come out recently investigating these topics, and there was one that I wasn't planning on bringing this up, but it just came into my head as in this discussion, and it was linking like doing an analysis to really try and link land use change to infectious disease
Right.
outbreaks. And it's something that we've talked about on the show. And it's something that kind of gets tagged onto all of these articles that you might read in popular media or otherwise about zoonotic, that is, diseases coming from animals to humans, outbreaks. There's always a climate change link. There's always this kind of, as the climate changes, there's going to be more of these outbreaks and stuff like that. And this to me was one of the first that I saw that actually tried to like quantify some of these things. So deforestation, as you cut down the trees and have cities and people more close to wildlife, there's going to be more chances for these things to spread to go over. As you have your livestock closer to wildlife,
Right.
it can move to the livestock, move to the people. So I didn't get a chance, like I said, I wasn't planning on talking this, so I didn't get a chance to go through that paper in depth, but basically it was like they were, making the correlation between these things. So it's, the Ebola situation is kind of an example of that. If this is indeed uh, directly from animals to humans, it's still possible that they find some link that they didn't,
Yeah.
that hasn't been found yet. But anyway, so that's the Ebola update. A little, it's good that it's not growing super, super fast, but the fact that it's a distinct strain or a distinct lineage of the virus is
No worrying. Yeah.
a little bit worrying. Yeah.
Okay, well, let's go from good news to bad news then. Let's take the sweet and the sour, the yin with the yang. Malaria. We've not talked about malaria for a little while actually on the show, but obviously,
On our infectious disease
no,
podcast that we've been doing for
yeah,
years. Thank you.
nice little plug there. But we have touched on it in the past, and obviously there's a lot of research going on to it, which we have touched on. So, background on malaria, obviously, it's caused by a parasite, Plasmodium, numerous different species of Plasmodium that cause it. Some that do cause infections in humans, and some that don't. Obviously, it's transmitted by mosquitoes. It's thought to be one of the biggest cause of deaths in the world. Around about
In terms of infectious
yeah,
disease, I believe it's still the largest killer every
yeah,
year with 500,000 deaths.
exactly.
Although, hey, maybe Corona catches up this year if certain
Usurps it
countries
off
just keep letting her
the
rip.
top of the podium. So yeah,
Yeah.
so around about 400,000 to 500,000 deaths per year. Around about 90% of those in Africa. So although it is seen in Southeast Asia and other parts of the world, Africa is the
South
South
America.
America. South Africa is the big one. And the worrying news that was published late last week in Nature magazine is there's been a drug-resistant strain found in Rwanda. So this strain's been known to be around for about the last 10 years, but only in Southeast Asia. But now it's been found in Africa. So obviously the concern is, obviously it's in Africa. Now can it spread throughout Africa? So at the moment, from the genetic testing they've done, it's they think it's more through mutation rather than actually being deported there and moved from Southeast Asia to Africa, which is obviously worrying that suddenly the malaria parasites discover this ability to mutate. And actually, what it's resisted to is the primary frontline drug, which is, and I'm going to screw up the pronunciation here, but I will do my best. Artemisinin, Artemisinin, which has been the frontline drug for a number of years. But resistance isn't anything new. Obviously, chloroquine, which is the precursor to hydroxychloroquine, which is obviously quite big in the news with the COVID fame at the moment. So chloroquine was actually discovered, and that's what you get in your gin and tonics. One of the quinines, discovered in 1934, and it took about 16 to 20 years for resistance to develop to that drug. But now for this artemisinin, this is the big frontline drug, and the fact that we now have resistance to that, it's being described as a major threat to public health. That we now have this. So as we said, it's the first time in Africa. The paper that was published, it's a collaboration between the Institut Pasteur, the WHO, not the band WHO, World Health Organization, the Malaria Control Program within Africa, and then Cochin Hospital and Columbia University. So actually what they've been doing is taking blood samples from patients, and over a short period of time they tested 257 patients, and about 7.5% of them showed the particular mutation to show resistance within this parasite. So not a huge number, but obviously the resistance,
it's only going to grow.
Exactly that. And I think the worrying thing for this is obviously there's a lot of research that's been going on to malaria in the last 10, 15, 20 years, particularly, we've talked about the Gates Foundation before. This is one of those diseases that they've, put on their hit list that they're going to eradicate and have vaccines for. So the fact this has occurred, great that we spotted it, because maybe it wouldn't have even been
Mm-hmm.
spotted with all the money that's there. But a little bit concerning that, this potentially pushes the fight against malaria. It's a massive, I've seen a couple of journalists comment on this story saying, this is highly significant. This is one of the biggest moments in malaria in the last 10 years, and not in
Mm-hmm.
a good way.
Yeah. No, for sure. I remember in like undergraduate biology and even during my PhD when you talk about um, parasites and drug resistance and these kind of studies to like the spread to track the spread of resistance and stuff. The resistance mutation in Southeast Asia, that was what everyone talked about, was like it's there.
Right.
Thankfully Southeast Asia isn't as bad as sub-Saharan Africa, but the worry is that it's going to spread, like it's somehow going to get there. And people that did talk about travel, right? Our globalized interconnected world is how
Yeah.
these things, someone with that malaria strain would go from Asia to Africa, and a mosquito would bite that person, and then that mutation would be in circulation. But this is almost even worse because it's
It's a
like
natural
it,
mutation. Yeah.
it's a natural mutation. So I would be interested. There's a couple things that popped into my mind. I'd be interested to know um, how similar the mutation is. Like, what is it the same mutation, and how did they determine that it's not imported from? So that to me says right away that there must be some kind of, it must be slightly different. So maybe it's producing the same effect, but it's different.
Yeah.
It's a different mutation genetically, right? Interesting, but yeah, also terrifying in the sense that here it comes. But I mean, this is not wholly uh, unheard, like
Yeah. It's not unexpected.
unthought
That's
of.
what parasites do,
Yeah,
don't they? Yeah.
unexpected. That's the well, and people have been, just like people have been warning about viruses like coronavirus leaping into humans for the past 15, 20 years.
But that
People
will
have
never
been,
happen, Flash, will it?
yeah, right. That would never happen, right? Um, People have been talking about malaria resistance and how that's like it's only a matter of time before a parasite or a virus or anything, gets resistance to something that's attacking it, right? So yeah, not great, really not great. Hopefully, maybe it spurs like a burst of movement in the research and say, hey, look at how it evolved it. Maybe that gives you like I said, if it is a different sort of genetic and then mechanistic pathway into how it's getting around the drug, maybe that provides some clue as to what the next drug could attack or something. You never know. So that's kind of me just being very optimistic about the situation. The question now is, will they be able to control the spread of that resistance mutation? And I don't know how you're going to do that.
That's the
I
scientific sound
guess,
you hear there of Flash
yeah,
considering how he's going to do that.
a bunch of scientists all just with hands in their forehead. Shit, what are we going to do now? Um, yeah, my concern, a bit maybe flippant, off topic, whatever, is how long is it going to take now for all these you know a-holes that are already, well, coronavirus isn't real, or it was created by Bill Gates to chip us all and all this shit. When are they going to get wind of it and then be like, oh, see, no, there's Bill Gates, he manipulated malaria too to fucking kill more African kids? It's just,
You really have
sorry,
been
maybe I've
jaded,
been
haven't
on.
you, Flash? By hopefully not just by our
a
podcast, but by some of the
little bit.
other, lateral thinkers out there, should we
Well,
say?
lateral thinkers, that's a very generous term. That's a very
Hey,
generous
Flash, some of
term.
them might be listening to this show, and as we've already discovered, we can't afford to alienate any of our listeners because we just don't have that many of them.
Well, I don't want to, and I wouldn't want to lose those people, because hopefully they could come to a better understanding of how biology actually works, how diseases actually work here at this show. But yes, I have been a little jaded, as it might show. Maybe I've just been spending a bit too much time on the old Twitter machine, which
That'll do it to you.
probably shouldn't
That
do.
and the heat, that'll do it to
Um,
you.
yeah, it's true. It's true. But yeah, that is, very, very concerning for people where malaria is prevalent, and for the world, because like we were talking about links to climate change and diseases and stuff. It's not just about zoonotic diseases coming from animals like bats and other things. If the range of the mosquito that carries malaria and dengue and Zika and all these other ones, if the climate gets a lot nicer and this mosquito can move its range, extend its range, well, guess what it's bringing with it?
Well,
Drug resistant malaria.
and
So
you mentioned, Zika has been quiet for a little while, hasn't it? But no, you're right. And I think there's, I guess in a way, we always joke about the British weather. I'm fortunate to live in the UK where the weather hasn't been supportive for a number of years for mosquitoes, and thus for the diseases that they can
that they bring, yeah.
but I know on the veterinary side, there's been a lot of work done over the last few years. Eric Morgan, who is at Belfast now, was at Bristol, was a big proponent of this, looking at climate change, whatever, and basically, the climate in the UK has been ripe for mosquitoes to be established for around about the last 15, 20 years or so. They just haven't
Yeah.
established themselves here yet. But today it's 29, 30 degrees here. This seems to be the new normal in terms of our summer. We're getting hotter and hotter.
Yeah.
It's there, and I think I remember seeing a paper once that was talking about, actually, well, the UK is okay because it's an island, you know. So as long as you quarantine the food, or shipments coming in, which we don't do, or you treat the shipments coming in, then you'll be okay. But actually, this paper was somewhere, well, actually, if the whole of Northern Europe gets warm enough, then the mosquitoes literally don't have to fly the distance; they'll just get carried on the wind over as well. So
Yeah.
they were talking about
Yeah.
the
Yeah.
transmission in shipments of things, but also actually climate change will actually just go supersonic. They'll go Top Gun, shall we say, and blow them here. So yeah, I don't want to be alarmist. We don't have malaria and we don't have Zika and things here, but I think we're going to see, as climate change happens, we're going to see these diseases move more and more and wider around the globe.
Yeah, unfortunately, I think that's the case. And I mean, to your point of like, well, someone who's saying like, oh, well, we're an island, so we can just quarantine these shipments, or we can just, do this. It never works.
No,
It never works. You can't, and this is why travel bans, in terms of, these viruses, the corona situation that we're talking about, it's like, yeah, it can buy you some time and stuff, but generally when you put in a travel ban, that just pushes people underground,
yeah,
and then you don't even know who's coming in.
yeah.
Then you don't know who's coming. Yeah, so it's really impossible. Here's another side note. I rewatched the movie Contagion. I don't know if you watched that one. And I kind of avoided watching the disease movies when the pandemic first started, because I was like, yeah, I've seen them. Is this really what I want to be doing right now? Uh, but my lovely wife Teresa hadn't seen, or had seen so long ago that she didn't remember. She hadn't seen Outbreak, the great '90s
That
action,
was Dustin Hoffman, wasn't it? Is
scientifically.
that?
Yeah,
Yeah.
that's right. And Cuba Gooding Jr.
Sorry.
and um, Donald Sutherland and Morgan Freeman.
Oh wow.
Star-studded
Yeah.
cast. Star-studded cast. Scientifically inaccurate.
When's that
Um,
ever stopped a film
but
flash?
but great, 90s action movies. If anybody knows me or has listened to this podcast, I'm a sucker for a 90s
Well, to be fair,
action
you're
movie.
looking fairly diehard here today.
Yeah, I know. The wife beater, yeah,
Yeah.
it's hot.
Yippee ki
Yeah, yippee-ki-yay.
In editing, we'll just have to overlay that so we get it perfectly in tandem.
Yeah. Um, great, great movie. Great movie. One of the reasons that I decided to do what I studied, was because of Outbreak. It had
I
such an
thought you were going to
impact.
say
But
because of
Contagion,
diehard. I was struggling to see the link there, but okay.
no, 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 Outbreak. But Contagion is actually a pretty good representation of how these things go. And as I was watching it, as me and Teresa were watching it, it's like all these phrases that are now commonplace: social distancing, transmission, like all these things that are now baked into the current. We're in this movie that was made in
Right.
like 2011 or 2015 or something like this, and it just like I was rewatching it with a newfound respect for the movie. I was like, you guys did a good job. You did a great job. So if you want to, people want to take a look at that Contagion. It was, maybe it's not the most exciting movie, and it got some buzz, I know, in the scientific community when it came out, because people were pretty fairly impressed with the accuracy of it. It's obviously not perfect, but even down to the level of like misinformation and public health agencies trying to get people to get on board with these things. And there's a great scene where they're trying to figure out, like, it's local public health officials, and someone from the CDC is telling them all this information. They're like, well, we can't say that. That's going to cause a panic. What are we going to do? Like, we can't do that. How do we message this? So all these things, it was brilliant. And the reason I bring it up is obviously because, well, maybe these things are even going to be even more part of our psyche moving forward, like with what we were just talking about with climate change and things like this. Maybe that's a silver lining of the situation that we're in right now, is that people gain a new respect for these things and start to try and turn the tide against the factors that are going to increase them or whatever. Now, as we already mentioned, I'm very jaded by seeing all the people that are actively doing the opposite, but I'm still an optimistic person, Brad. I'm sorry for the tangent.
No, no, not at all. Tangents are always good. They take some. Do you know what? I've not actually seen the film, and I should stick it on my viewing list to
Do it.
watch at
You'll
some
be
point. Okay.
impressed. I
Noted.
think you'll be impressed.
Well, you've taken us on a tangent, Flash, but let's stick within the tangent that was infectious disease and research there. So we've done good news, we've done bad news. You've got the next story with infectious disease. Is it going to be good or bad? What's your view?
Ah, man, I guess it could be both. Anyone that knows me knows I'm an ultimate fence sitter. I don't like to choose sides very often. I like to, run hard down the middle.
You should really
Um,
be Swiss rather than Canadian.
no,
Okay.
don't like the Swiss. I'll take a hard position on that. Don't care for it. Don't care for it. No. Any Swiss listeners, I'm sorry. Your country's beautiful.
Yeah.
You just need to be a little more welcoming to outsiders.
Well, always
Um,
fine with me, Flash. I think you might find it's just you, but
Could be, could be. It's probably because they suck at hockey and they're tired of getting beat by Team Canada.
there we go. I knew there was going to be a hockey link in there somewhere.
No, so the next story is, and I mean, maybe people are tired of SARS-2 COVID news, but this one I thought was interesting. Caught my eye, and unfortunately, I didn't have a lot of time to go through the nuts and bolts of it. So I'm going to do my best to kind of give the sort of you know overhead view of what they found, but it pertains to the origin of SARS-2. And obviously, we've talked about the lab leak hypothesis and all this stuff, and how most of the scientific community is pretty, you know, convinced that it didn't come from a lab. There's lots of reasons to believe that or to think that. Clearly, that could change if someone from that lab shows us evidence that they had it all along. But the latest thing is that they've done, through some genetic analysis of the SARS-2 genome. There's reason to believe that this thing has actually been circulating in bats for decades.
Mm.
So it's possible that this actual strain, this SARS-CoV-2, as we know it now, has been in bats for a long time, which means that it didn't use the intermediate host to get to us. So there was the idea that it's bats, something else, pangolins was the culprit that we had been looking
Yeah.
at, and then humans. Now, obviously, again, new evidence could change this in an instant, but this is what one paper published in the Nature set of journals is proposing. So the difficulty with this, with doing these kind of a genetic analysis, with coronavirus in particular is that they tend to do what's called genetic recombination very frequently.
Right.
And so, if you don't know the term genetic recombination, basically, if two pieces of DNA come into contact with each other, they can swap genes. So, this process happens in humans when you're born, when a new baby is made, because the chromosomes, half of them come from the mother, half of them come from the father. They actually meet in the egg, in when sperm meets egg, they come together, and there's a process where they actually physically interact. And during this physical interaction, you can swap genes, like sections of one chromosome will fuse to another and vice versa. And that's why you can have a different composition of genes than your parents. So you'll get some from your parents, or some from your mom, some from your dad, but you won't get the same, it won't be
Yeah.
identical to either of your parents, right? That's the process of recombination. This happens all the time in things like bacteria and viruses because they
They're
are like their
replicating all
DNA
the
is kind
time,
of,
and yeah.
they're replicating all the time. They're in close contact with each other. And just like, in general, they're single celled in terms of bacteria, or not even a cell in terms of virus. So their DNA is out there. It's mixing around and it's doing stuff. So recombination happens a lot. And for coronaviruses, particularly so. So this makes it then difficult to do these genetic analysis, because when you're comparing the different strains, not every section of the strain of the genome of each strain has evolved at the same rate.
Right.
Like it could have had this insert from another one, which totally then bungs up the analysis if you're trying to look at it from a evolutionary perspective, or what we call a phylogenetic tree. Where it's like incrementally, how did one thing evolve to the next? If you just slap a gene in there, that's going to throw that whole analysis off. So what you need to do, and what this paper was concerned about, was finding regions of the genome, the SARS-2 genome, that hadn't undergone recombination. And there's different ways that you would identify a region that has undergone recombination or not. Now, none of those methods are perfect.
Right.
And the authors mentioned this. And so what they did is they used like 3 or 4 different computational models, methods that you would do in this type of analysis, standard things, but they used a bunch of them to try and see, like, can we come to a consensus with this? So I thought that was a nice part of the study too, is that there is no agreement really on, has this area undergone recombination or not. Obviously, it's easier to tell in some places if you just see like a random section of a another organism or another strain of a virus just plunked in there and you've never seen it before. You get some
Right.
clues that it's there. So there's clues as to what has and what hasn't undergone recombination. So what they wanted to do is they wanted to identify the regions of SARS that were evolving as like one entire piece. So like I said, without recombination. And then you compare that to the other known strains from bats and things like pangolins. And this confirmed what they already kind of knew, is that SARS-2 on the whole is mostly related to, or most closely related to, the RATG13 strain of coronavirus, which is a bat strain. So in the previous studies where people were trying to look at the origin of SARS-2, they were looking at the spike protein specifically. Obviously, you would do that because that's the protein that um, attaches to the human cell.
Right.
And so it was like, how did it evolve this ability to attach to the human cell? Um, and they looked at the what's called the RBD, the receptor binding domain. It's a portion of this protein, and this is where they found that this section of that protein was genetically more similar to coronavirus in pangolins. So that's where the pangolin idea came in as the intermediate host. So there's 2 reasons, sort of mechanic, evolutionarily, or there's 2 mechanisms as to how this might have happened. One is that SARS-2 got this ability, got this section of the spike protein by evolving over time in pangolins. So it had been in pangolins for a while, sort of evolved, and pangolins have a similar receptor site to humans. And so that's how this thing happened. Now, that's unlikely because when you look at the rest of the genome of SARS-2, it's more closely related to
To
the
the
bat
bats.
one
Right.
than the pangolin one. So the second thing is that, well, maybe it was recombination, what we had just been talking about. This SARS-2 gets into pangolins, and then this specific uh, binding domain portion gets plunked into SARS-2 from the pangolin version. But there's no evidence, based on these tests that we have or these clues that we have for recombination of the genes of the SARS-2 spike protein. So that leads to, we don't know how that got there. So with this new analysis, what they're proposing and what they believe is possible is that the genes for the spike protein and this giving coronavirus SARS-2 the ability to infect human cells was actually passed down from a common ancestor of the three strains we were just talking about: the pangolin strain, SARS-2, and RATG13.
Which is the
So it's
bat one. Yeah.
possible, which is the bat one. So it's possible that they all have the same common ancestor, and that's where this originated. So in order to try and tease that out, they wanted to try and find, when did SARS-2 split from this common ancestor. Would be an important question in terms of where it came from, and would have implications on what we should be doing to prevent other coronavirus outbreaks. So they looked at all the mutations they could find that weren't a result of recombination. You do that, and then with those mutations that you believe are not caused by recombination, if you know the estimated mutation rate of a virus, which again, it's an estimation and there's not total agreement on what mutation rates are, but this is where, they had their multiple analysis and stuff to try and account for this. But in theory, you can look at any, organism's DNA over time if you have samples that are time marked, and get an idea of how often they the nucleotides in the DNA sequence change, right? And that gives you a mutation rate. So if you look at the areas that haven't undergone recombination, you have this estimated mutation rate that you can then go back and see how long it would have taken for these mutations to accrue over time.
Right.
So you're looking at the three strains and then going backwards to say, well, how long would it have taken until they, by chance or probability, would have been the same thing. And so the lead author, what do we have? Yeah, so when they do that, they went back and they found that it's possible that over a century ago, so over 100 years ago, there was a single lineage or strain that gave rise to all three of these: the SARS-2, the other bat one, and the pangolin one. And the lead author of this paper also said that she thinks, oh, I don't know if it's a man or a woman, actually, sorry.
They think.
They think that it's possible that original strain could even have infected humans, so that the original strain
So
already
that
had
was
the
going to be
ability.
my question, actually, when you said, so is there a way that this actually has gone full circle, and then that's why it just keeps perpetuating, and that patient zero was actually human, and then it went from us into bats and pangolins, and
Yeah, well, I don't know if you could ever say that.
I just did.
But yeah, I don't know if you could ever prove that. Um, Basically, their timeline goes that the pangolin version that we've been comparing this to, or that the spike protein part is related to diverge from the SARS-2 and other bat one first. Then in the 60s and 70s, that the lineage split into two, creating the two bat versions that we now have. And sometime between 1980 and 2013, the closely related bat strain RATG13 lost the human receptor binding ability, but SARS didn't. And that would
Right.
be a plausible pathway as to how this thing happened. And then it would also mean that SARS-2 likely came directly from a bat into a human. And this is where, again, we would need more studies to kind of tease this out because, and I wish I had more time to read this paper because they do acknowledge the fact that the SARS viruses that we know of in, or SARS-like viruses that we know of in bats do seem to be kind of geographically split amongst like bat populations. So how one species of bat would transmit it to another species of bat. Like they could be all harboring these similar viruses,
Right.
right? But I know that this is one of the criticisms is that people were like, well, these bats weren't even active at the time of the outbreak, and RATG is not that's it's the most closely related one, but it comes from bats in a different geographic location, and those boundaries are largely kind of maintained. But so the authors suggest that we just need to do along that geographic gradient of where RATG is found and where SARS-2 was found, sample bats in between that all the way. And you might find these intermediate steps, or
Right.
you might find a place where they overlap, that kind of thing, which would again sort of give you then an indication of where and when those two viruses split. There might be other ones that fill in those gaps, right? Um, and then in reading this paper too, I found it interesting that because a lot of people again with the lab leak thing were talking about, well, how did it get this? How did it get this ACE2 spike protein receptor? That seems interesting that it would just like be able to infect humans like right away. And there's a lot of reasons why that could happen. One being that uh, it was in humans for a while, and was passing around and we just didn't know about it. So maybe there's these unknown outbreaks somewhere in China where people got mildly ill or they didn't get ill, but the virus was in them,
Yeah.
further adapting to grab onto this protein and really get that tight bond. And of course, there's other sites that are involved in this too that we're not talking about, but that's where that could have happened. Um, but it's also possible, like this paper said, and like a lot of the references that they cite in this paper, is that a lot of coronaviruses have these ACE2 spike binding
Okay.
proteins. Like it's not a
It's not
unique
unusual.
thing,
Right.
It's not unusual. So they think that this original lineage probably had it, and so could infect humans, and that the other RATG lost it. But they cite a number of papers that talk about coronaviruses having these ACE2 receptors. So it kind of just goes like the good and bad of it, I guess, is that while it's a bit more evidence that it's not the lab leak thing, which is good. Um, it's a little bad in that it's like, holy shit, these things there's probably a lot more of
Yeah.
them,
Yeah. Yeah. Yeah.
which again, people have been saying for years. I looked at some of these papers citing ACE2 receptors in bat coronaviruses, and they're, some of them are, 5, 6, 7 years old. So yeah, it's not a new thing. And it just kind of shows you how there is ways in which these things evolve. And it's great that we got the genome right away. That's another thing they mentioned in the paper,
Right.
is that our ability to get the genome of SARS-2 right away allows for this kind of analysis. Unfortunately, it wasn't quick enough that we could do something about it. But they also kind of mentioned that it's like, hey, like with all that we know about coronaviruses, we should have been in a way better position to detect this and do something about it right when we saw it first happen. And that's a bit on China, but it's also a bit on the rest of the world too, in that like this is why surveillance for these things is so important, because this analysis points to the fact that there's probably a bunch more of these viruses circulating around in bats. And I guess the last good thing I would say is that if this thing has been circulating in bats for 100 years, it only happened now, like once, like and that's what they mentioned in the paper. I think the direct line from the paper is like some unfortunate person in 2019 got it or maybe it was an article that I was reading that was like reporting on the paper. But and that's the thing, like if this thing has been in there for over a century, it's like kind of shows you that it just takes one, but
Well, and when you first started talking about this, and obviously we just come from the story, with malaria and mutation resistance. So I presume, obviously, from the technique that they've used, they can go back and look along the lineage to show it has been a progressive thing, as opposed to, well, it's just a random mutation that this virus has done that's made it able to jump from bats or pangolins into humans.
yeah, I mean, if you that's the idea, is that if you look at if you look at the places that don't have recombination, that gives you a longer view into the past, right? Because they're more slowly changing over time, whereas recombination messes that whole thing up. But if you
Right,
have a stretch of DNA, two speed, two strains or whatever, they're this much difference, and how often or what the rate of accumulating new changes is, you can then you can go back and find out how long it would have
right.
taken for them to be the same thing.
Got
That's
you.
the basic idea. Yeah. Maybe I should have explained it that way
No,
in the
no,
in
no,
the
no.
beginning.
No, not at all. And
But
it's only,
that's it.
yeah, no, and it's only as you were talking, and you kind of answered the question, so I wasn't going to ask it, but I just thought, actually, for any listener out there that caught the tail end of the last part of the story in malaria and this part, that was my
Mhm.
initial thought. So I just, yeah,
Yeah,
interesting.
yeah, yeah. Yeah, yeah, yeah. It shows you, and like I said, like they did it in multiple ways to try and balance out. We don't know for sure. A lot of these things, it can be subjective. At some point, you have to say, is this recombination? Is it not? And there's a bunch of criteria that you would use to determine that. So it seems like a robust analysis. I'm going to go back and read through it again. But honestly, like some of this genetic analysis stuff is even above my pay grade, which is zero. Um, since I finished my PhD. But even in my PhD, I don't know if I was going this deep, especially in viruses. It's different
Right, yeah,
creatures than the worms and parasites that I studied. But I thought it was really interesting. I thought it was really cool. And it kind of, to me, stuck out because, again, it gives you another possibility as to why it's not just lab leak. So that the evidence is accumulating more and more for the natural, quote, natural pathway for this thing, which again it seems improbable, right? Like that's the thing when you talk about these things with people that don't know genetics, don't know viruses, don't study that stuff. And I admitted, even someone who has studied it, it seems improbable. Like some guy just ran into a bat and a bat sneezed on him, and he, like, but you got to think about how many times that happens in human history, how many times that happens in the world,
yeah.
and how many of these viruses are there. And it just becomes a numbers game, and the probability just goes up and up and up and up as to what this could be. And this just shows, looking at the genetics of the thing, is that there's a probable pathway that you can point
That you
to,
can
that
see
this
it. Yeah,
thing had been in there for hundreds of years. And
and I guess at some point it
so
gets to a tipping point, and there it is,
yeah,
and yeah,
the right guy, the right bat, they lock eyes, the music starts playing.
a bit of Barry White in the background. The
That's
rest is
right.
history.
That's right. So I don't know. I thought that was interesting.
No,
Maybe if people are interested in more, tweet at me, tweet at the show, use the contact form on the website. All that stuff. Get in touch, and I would be willing to even just go back and forth with people about this, or do another more in depth thing on it.
that'd be good.
But
Well, and we'll put the links out to the stories as
yeah,
well,
yeah,
obviously, as
it'll all be
always.
there.
So yeah, cool. One more quick story. I think you got one there.
Mm-hmm.
Sorry to interrupt your quick refreshment beer there, but I'm out of my refreshments. Oh no, actually I'm not. So you can take it away while I refresh myself.
What is the next one? I thought the next one is you. We're
Oh
going to
no, you're
space,
right. It
aren't
is
we?
me. We are going to space. I take it all back. So yeah, okay. Well, a change of tack then from infectious disease to the cool world of physics and space, which obviously, as
We
regular
know
listeners,
nothing about.
will know, we know nothing about, but we love it dearly. It's only a short story, really, but caught my attention. So it was all over the news last week with the SpaceX and the Dragon capsule landing.
Right.
So
They
that
sent two dudes up. They made it and they came back.
Yeah, they were up there for a number of
And
months.
the rocket that propelled them into space landed, right?
Yeah, so it's totally reusable. So it's it's the first commercial transportation of humans to and from the International Space Station. So that
Mhm.
alone, amazing achievement. It got rightfully, and this is what I love about the whole SpaceX thing is I think we've become too complacent about space. We got to the point where space shuttles were taking off and rockets were taking off, and it wasn't even making the news.
Yeah.
Whereas at least with
Yeah,
this
yeah.
thing, it is getting the news. It's getting obviously a lot of coverage on YouTube. I know myself and a lot of friends, especially with kids, um, are tuning in to watch these takeoffs and then the re-landing of the rocket because it's
I was
incredible to watch.
surprised. I was surprised at how many people I knew watched the launch
Right?
of the rocket. Like I was like, "Holy shit." Didn't think that people I didn't watch it, and
Yeah,
I didn't think that people were that into it, and then I saw friends in WhatsApp groups posting the pictures being like, "Hey."
yeah.
And I was like,
I
"What is this?"
I'd set an alarm to make sure I watched it and stuff, and then
Oh.
obviously the tangent to that, not part of the story, is then the whole Starlink satellite network that SpaceX are
Mhm.
putting up there. So even with the naked eye, you can see a lot of these things on a clear night. So I won't recommend apps, obviously, because we're not paid by them. But go and have a look on your app store and download some apps that will tell you what's in the night sky. Or
Mhm.
Virtual Astro on Twitter is a good one to follow. He'll tell you a lot when you can see passovers and stuff. But anyway, so obviously the Dragon capsule relanding or come back to Earth got a lot of coverage. What didn't get as much coverage, and what I want to just flag today, is last week there was the next wave of prototypes that SpaceX are working on are their Starships. So we're not quite at USS Enterprise level just yet. Um, but the next generation Starship vehicles, they're called, basically they're designing to be able to go to the moon, but also to go to Mars. That's the big prize. So they did a test earlier in May of the code name for it was SN4. SN4 didn't go very well. It was a static test. It blew up on the landing pad or on the launch pad. But SM5 was tested last week. Now, SM5 was a step along that path, and it actually was a takeoff. So it reached an altitude of 150 meters, and then it deployed its landing gear, and then it touched down again. So the whole thing was only about 40 seconds long.
Hmm.
But the test was for the technology. So the technology to get us there it's called the Raptor engine, and it's powered by liquid methane rather than liquid hydrogen. A lot of these and liquid oxygen. And basically, the plan is that within the next decade, within the next 10 years, SpaceX will put one of these on the moon. Um, and the pin that they have put in the ground, or in the moon, or in space, is that by 2023 they actually have somebody that's paid to do a fly loop around the moon. So actually, it's a Japanese guy. He's a billionaire.
By 2023?
Yeah. So Yusaku Meizawa. He's a Japanese billionaire. Made his money out of art and fashion. And
Oh,
he's
seems like a perfect guy to pilot a highly
well, he won't
technical
pilot. Yeah,
spaceship.
he won't pilot. But basically, he's paid to do a loop around the moon. It will last.
Oh, he paid to be a passenger.
He paid to be a passenger. He will be the first
He's funding
passenger.
the thing.
I don't think they've disclosed how much he's paid, but it obviously has paid a big chunk towards SpaceX development costs. But then I started digging into this Starship thing. I'm a Star Trek fan. I hear the word Starship. I want to see what it's like. So the test was in South Texas last week. As I said, reached altitude 150 meters. It deployed its landing legs and it touched down again. And in this prototype, it just used one engine, so one of these Raptor engines. But the actual Starship itself will use 6 engines, um, which potentially will give it the ability to carry up to 100 people. So a payload of around about 100 plus tons. Basically, Elon Musk, the CEO behind SpaceX, has basically said, he sees it as a way to transport and colonize the moon. He wants to see humans as multiplanetary,
Yeah.
species, not just tied
Yeah,
into
yeah.
one. Um, for me, the interesting way is the way it scales up. So we've got this prototype with one engine. The plan is on the final one, we'll have 6 engines, but actually, we need to get it out of the Earth's atmosphere, and that's the big piece.
Right.
So for that, you need super heavy. is what they've prototyped it. So it'll be a super heavy rocket to get you out of the Earth's atmosphere. That will have 31 of these Raptor engines to blast it out of the atmosphere. But then there'll be separation, and then the Starship would carry on to the moon or to Mars, or wherever it's going to go, just with the 6 engines, because obviously it doesn't have to then make all the effort to escape Earth's gravitational pull and stuff. But yeah, kind of amazing. What I really liked is, as I was researching this, some facts for Super Heavy. So Super Heavy will be 120 meters tall, 9 meters in diameter. As I said, the ability to push out a payload of 100 tons. I really recommend people to go and have a look at the SpaceX website. I had a look at it today when I was doing some research. There's a user guide on there for the Starship already, which sounds impressive. When you click on it, it's not you push button A to take off and push button B to land. But
Yeah.
she does give you a lot about what they're trying to do and how they're doing it, and some of the science behind what they're having to overcome to do. And it is a little bit of a sales pitch. Obviously, they are looking for investors to try and go. But I just found it fascinating that there's a user guide out there already and what they're doing.
Mm-hmm.
Yeah, we're almost at the end of 2020. I know a lot of us want to see the back of this year fairly promptly. But yeah, by 2023, we're going to have a guy doing a loop around the moon.
Allegedly.
Allegedly. So, a bit of a longer range pin, but let's keep an eye on that one and see how it goes. But I'll definitely
Yeah.
do SpaceX a little bit more closely than I have been.
So how is it? How is the system to get out of the atmosphere different than the one that they're using now? It's just that it's a different engine because the ship is going to be bigger,
Yeah.
and so they need more
So they need,
thrust.
yeah, exactly. So at the moment, like the Dragon capsules are only carrying a maximum of 2, I think maybe 3 people, and
Yeah.
a reduced payload. But if we're talking about carrying 100 people
Yeah, yeah.
or a vast
So
amount of cargo, then it needs a hell
it's
of a
gonna
lot
be
of power to do that.
a big boy. It's gonna be a
Yeah,
big boy. Yeah,
very much.
interesting. Did you see if it also will land the rocket that sends it up? Will
Super
it
heavy will
also
be
be?
reusable as well, I believe. Yeah,
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 nice, nice. That's pretty awesome.
yeah.
Does the craft itself that will zip around between the moon and Mars and stuff like that, does it look cool?
The pictures I've seen, you go onto the website and
Because
they've
the
obviously
Tesla truck to me looked like shit. I know some people liked it, but I did not like it.
To be fair, it just looks. If you asked a child to draw a rocket, that's
Okay.
what it would draw. It looks a little bit phallic.
Yeah.
I'm not going to lie. With some, I'm not even sure if it's got fins on it. I think it's got fins on there, but
Yeah.
it looks like you said to a child, "Here's some crowns, draw me a rocket." Your traditional cigar shape
Yeah.
with some
Yeah.
fins on the
Yeah.
back.
I
But
guess, well,
tried and tested.
yeah.
It's worked for hundreds of years in science fiction. So
Yeah, that's true. That's true. So would the idea too be that this thing could land on the moon and then continue to Mars? Do we know that?
no. So I think the plan would be, well, this one's going to go to the moon. It's not going to be a
And then come
bust
back
and come back. This one's
and
destined for
then
Mars. But yeah, who
okay.
knows? I guess fuel would be the big thing. But
Yeah, and then once it's in space, it's just rocket thrust and use the
yeah,
momentum it's got. Yeah.
yeah,
Interesting. Hey, cool. I
yeah.
mean, I dig it. I dig it. I know some people hate on Elon Musk, and he's a weird dude, and I disagree with his stances on coronavirus issues, but his space shit's cool.
No, exactly. You've got to give him credit for that. So yeah, watch this space, as I
Ooh,
say. See what I've done there.
I see what you did there.
Yeah.
Yeah, no, that's really cool. That's really cool. People on Mars, interplanetary species. As far as we know, the first ones to do it. So
Hey,
we
well
claim that.
then let's watch the virus mutation from Martian DNA being inserted in. Jeez, I think we've got problems now. Wait until that
Yeah,
kicks off.
you had to bring it to that. You had to bring it to that.
Hey, got to feed the conspiracy theories somehow.
Yeah, that's right. That's right. Well, hopefully we've given them enough fodder to misinterpret and misuse. Um, why don't you wrap it up for us then?
Okay, well, so also we started talking about Top Gun to start. So it would be
We
unjust
could
not
do
to
a
go.
Twitter poll to drive our engagement. Who's the Iceman? Who's the Maverick?
No, we don't need to vote on that. We all know the
No,
answers,
we don't.
listeners.
I don't want to know the answer.
Um, but from that film, how How did it go the first time? I crashed and burned. How did it go the second time? Well, I'll let you know in the morning, but it's looking good so far. And I think, it's been a little while since we've been back in the seat together. And I don't think we've crashed and burned. So let's see what it looks like in the morning. You heard it here first, listeners. Watch out. Viruses might be jumping from animals into humans and causing some serious shit to go down. So
maybe
you heard it here first. If only we could find a way to go back and put some money on that. And there's actually, tracking into the Starship, resistance is futile, or is it? That's the thing, is resistance going to be the death of all of us? Quite possibly. Not that I want to be alarmist and feeding more conspiracy theories, but Flash, it's always been a pleasure. If people want to get in touch with the show, you can do so very socially distanced. You can use social media to do that. So it's at 2Brad for you on Instagram and on Twitter for the show. It's at Bradley W. Hayes on Twitter for myself. Flash, if people do want to socially distance but message you,
at bvampiredon. I'm always open to, see the deluge of shit that's on social media. So if you want to throw some shit my way, do it.
Well, please do. You got nothing better to do. It's been a blast, as always. Another rocket pun there, just as many as we can get in. But just before we touch down, then thank you, listeners. Thank you, Flash. And we won't leave it so long next time. And at the very least, we should try and record when we're together next month. I'm actually crossing the ocean to go and visit Flash and his lovely wife, Teresa. Fingers crossed.
As long as the authorities deem it safe to let a British hooligan into the country, then
I could be the first wave of the invasion. Who knows?
Yeah. I will vouch for you at the border if it comes to that.
Would be appreciated. We all need a character witness such as yourself, Flash. We would all be better in life if that was the case.
I don't know if I'm the best character witness over here, but we'll do.
You're the only one I've got, so I'll take it.
All right. Thank you to the listeners, as always, for tuning in.
Yeah. Be safe, Flash listeners. Be safe. Follow whatever your health advisors and whatever saying. Keep your 2 meters, 1 meter. Wear your face masks. Use your napalm. Do whatever you need to do, because we cannot afford to lose you. Cannot emphasize that enough. We can't afford to lose you. Flash, it's been a blast. Until next time, my friend.
Until next time. Catch you later.
Cheers.
Master.
Well, to be fair, I just relay. It's a pub in Wimbledon that relay the actual quiz, and I just relay his quiz to the masses in the pub.
Yeah. Just hosting.
In effect, yeah. But that's what I do. I piggyback on other people's success. So
you're doing a pretty good job here.
Hey, I'm like the parasite of this show. So, and I've not yet mutated. All right.